Okay, for this section, you will need both a ruler and a graphing calculator. So if you don't have those already, please go and get them. Otherwise, the introduction states that during the walkathon, their manager was keeping track of everyone's progress in the scatter plot below. These lines are, these points are definitely scattered. We're used to nice straight lines that form a nice linear equation. We're not going to see that. We can compare it though, because even though these points are scattered all over the place, we can realize a couple things about them, and that's what we're going to do in this introduction. First off, number 1 says we're supposed to summarize the data. Again, even though we can't really connect these dots in a nice linear pattern, we do see a pattern. We see that the amount of laps, once they increase, the money that we're making is increasing as well. So that's what we're going to summarize, is that the more laps they walk, the more money they make. Okay, so the more laps they walk, the more money they make. So we don't need a nice, pretty, organized line in order to understand that. Okay, in scatterplot vocab, what this is called is a positive correlation, because our independent and our dependent values have that positive correlation. As one increases, the other increases as well. Okay, now it's asking what was the average amount of money donated? Well, again, really hard to see when we have these points scattered all over the place. So what we're going to do is we're going to, since they're just looking for the average, an estimate, we're going to actually go ahead and draw a line that does kind of best fit this information. So we're going to draw what's called a line of fit. And I'm going to put that down here. The rules for a line of fit should have the same amount of points above the line as below the line. Because that way we do see a nice average pattern, that it's nice and balanced. Okay, really hard for you to see this ruler that is on my computer right now, but go ahead and put your ruler on the graph and kind of play around with it. See how you can go ahead and line them up so you have about 12 points on top of your line and 12 points below. Try to maybe go through 4 to help you out a little bit. Okay, mine is off. I think I can cheat. Let me see if I can move this guy up just a tad. Nope, that's too much. Okay, well that's about what it's going to have to be. Okay, so let me see what I have. I have about 2, 4, 6, 8, 10, 12, 14 above 2, 4, 6, 8, 10. Yeah, so mine didn't work. I am going to have to move it just a little bit up. That's a little bit better. Okay, so 2, 4, 6, 8, 10, 12, that's about a pretty good line of fit. Again, this is called a line of fit. Gives us a pretty good average of what we're looking at. Now, using that line, let's go ahead and answer these questions. What was the average amount of money donated? Well, that's going to show up at our y-intercept. My y-intercept is pretty close to 4, which is in hundreds. So we're going to say about $400. Again, what they're looking for is the y-intercept here. And we're using that average based off of our line of fit. Now it's saying what was the average price received per lap. Okay, well again, we're going to do the same thing. Price received per lap, this is looking for the slope. So how do I find the slope? I figure out how far I went up and over between lines. Okay, again, your line might be different than mine, but I'm going to use that point right there, and I'm going to use this point right here that look like they're pretty close to where they are, crossing on an integer. And I'm going to figure out how much I rose and how much I ran. So it looks like I rose to $400 for every 2, 4, 6 laps. So average price per lap, about $400 per 6 laps. So what is that for 1 lap? That is about $67 per lap. Okay, you could most likely have something else than I do. And this is where students sometimes get frustrated with scatter plots, is that not everyone is going to have the same answer. These are averages, these are estimates. So as long as you're close to 67 per lap, I remember first time I tried this, I was at 70 per lap. I'm close, okay? If you were down in the 35s, you might be off a little bit. But we're gonna say about $67 per lap. All right, with that in mind, we're supposed to write an equation that would represent the average amount of money made. So this is back to what we're used to. We know that we're dealing with laps, and we know that we're dealing with amount earned. We have the two pieces of information that we know. Whoops. I'm used to writing my L's like that. L and A. We know our amount earned is around $67 per lap plus about $400 in donations. Is that exactly on? Is that perfect? No, because again, this is a scatter plot. So what this is called is a linear regression. When you hear that word, when you hear those words together, you need to know that we're dealing with scatter plots. This is not an exact equation. This is just a linear regression, so we can estimate a couple of things. So if we needed to know, okay, well, what happens at the very end when everyone went 30 laps? We could throw that in there and we could get a rough estimate of how much money each person earned on average. Okay, so the words that we're going to be dealing with, line of fit, linear regression, understanding scatter plots, are definitely scattered information, but we can look at it and organize it into a nice little summary. All right, with that in mind, again, keep that ruler out and get your graphing calculator if not, and then get your notes and vocab out for the section. Okay, objective of this section is to represent, display, and interpret data involving two variables in coordinate planes, including scatter plots. Information with number 1 says data with two variables are called bivariate data. What we're focused on is the scatter plot part. A scatter plot shows the relationship between a set of data with two variables, graphed as ordered pairs on a coordinate plane. Scatter plots are used to investigate a relationship between the two quantities. Definitely not as linear as a linear equation, but again, we can see most of the time a correlation between them. We saw a positive correlation because as our laps increased, our money increased. We could technically draw that line of fit in between there and use that line. Sometimes we do have a negative correlation. As time increases, maybe the temperature decreases. Sometimes we have no correlation. Okay, it could be as time increases, this is the amount of cars that are driving by my house. There is no correlation. So sometimes our data is not related. But when the data is related, we can go ahead and see that correlation, which is what we have to do with real world example 1, and then describe the meaning in the situation. Okay, students, don't get very picky on this. Don't say, well, it was linear right here, but then it started waving all over the place, so I'm not going to say that it's positive because of that dip right there. As a whole, this pattern is increasing. So we are going to call this a positive correlation. We don't even have to look at what this is dealing with. We just look at those dots and see a pattern. Are they going up? Are they going down? Since there is a positive correlation, now let's go ahead and look at what we're dealing with. We're dealing with hours versus wages. Well, we said there's a positive correlation. So it looks like as the hours increase, the wages increase. And that's what we're going to say. As hours increase, wages increase. Okay, scatter plots are a nice quick representation of information so we can summarize that data. Go ahead and look at guided practice number 1. Okay, again, not being picky about whatever happened early 2000s right there, we can see a pattern that these points are increasing. So we are going to call this a positive correlation. What is it representing? It's saying that as the years increase, the amount of travelers are increasing as well. Okay, just a quick representation of summarizing that data. Now we're going to look at that line of fit that we did on our introduction. Scatter plots can show whether there is a trend in a set of data. When the data points all lie close to a line of fit, or a trend line can be modeled in the trend. So we already went through many of these different steps. We did make, the scatter plot was there for us. We determined that it was a positive correlation. We drew that line that tried to keep everything balanced. This is one piece that we didn't do. We didn't use 2 points on the line of fit to write an equation. We will do that later, but I'm also going to show you how to use a calculator. You can also estimate a slope and y-intercept for quick information, or use calculator. Okay, we already estimated. We will use the calculator. We also will use 2 points. And then we're going to use that line of fit to make predictions. So, real world example 1. Table shows the largest vertical drops of 9 roller coasters in the United States in the number of years after 1988 that they were opened. We're supposed to identify the independent and the dependent variables. We're supposed to answer, is there a relationship in the data? And if there is, we're supposed to predict the vertical drop in a roller coaster built 30 years after 1988. So let's go ahead and identify independent and dependent variables so we know how to graph this guy. Vertical drops depend on how many years since 1988. So vertical drop is our dependent, years since are going to be our independent. So now that we know that, let's go ahead and put together this graph. We know this is years since 1988. We know that this is the drop in feet. Okay, this might get kind of snug. Since we have to get to 215, since we have to get 215, we're gonna have to go by 2s. I'm just gonna stop at 16. We have to get all the way up to 400, so we're gonna go by 40s. Whoops, and 60 is not 40. My goodness, what am I doing here? Go away. Getting used to this new computer. Okay, so this is step 1 that we have to create that scatter plot. And understanding that once we get into the scatter plot, we're going to realize that, again, these aren't perfectly linear, but hopefully we will see some kind of trend. So in year 1, which is about halfway here, we have 151. Year 3, halfway, 155. Year 5. Another thing, tell kids not to spend a whole lot of time really analyzing this and making sure that they're exactly perfect. Again, this is a quick representation. That doesn't mean to get sloppy, but some students really want to spend a lot of time on making this perfect. Scatter plots are not perfect. Okay, this one right here, notice that we actually have 3 roller coasters that were made in the same year. Kind of crazy all together there. And then year 15, we had that 400. Okay, so with that, is there a relationship in the data? Yes, it looks like as the years increase, the size of the drop increases, the size of the drops. Increase. Okay, so they said that if that is true, if we do see a trend, we're supposed to predict the vertical drop in a roller coaster built 30 years after 1988. We are going to use our calculator here. So what I'm going to do is I'm going to write the steps that we're going to use down first, and then we're going to go through those steps. And the steps that we're going to do, we are going to plug our information into the calculator in order for it to look at that and put it together into one of its programs, which is a linear regression program, to give us the best line possible, the best slope for this equation, the best y-intercept of the equation. And in order to do that, these are statistics. So we're going to go to the Stat button, and we're going to have it edit. Once we do that, it's going to give us the table. List 1 is our x values. So we're going to plug all of our x values in list 1. List 2 is our y values. So we plugged in our information. Then we're going to go back to statistics, and we want it to calculate now. Okay, remember that earlier we called this a linear regression. So that's going to be number 4 on our options. And it's going to give us a couple numbers. It's going to give us A, which is the slope, and it's going to give us B, which is the y-intercept. Okay, students that are really good with calculators really like this because it's just kind of handy to plug that in there instead of making that line of fit, instead of estimating and finding slope and all of that. So let's go ahead and get that calculator out and try this. So if we hit that stat button, notice the stat button is right here. Whoop, don't look at that. Stat button is right here. I want to edit. And again, don't look at what I have. Sorry, I was cheating and tried this out earlier. Okay, list 1, all of our x values. So I'm going to plug in all of these by hitting 1, enter, 3, enter, 5, and so on. I would definitely recommend putting in all of your x values first. Don't try them as actual points. It goes a little bit quicker. So once we have those 9 in there, you can hit this right over button and go ahead and put in your y values, 151 and so on. Okay, I would recommend getting a graphing calculator, especially when we start dealing with some of the later concepts. This will be a lifesaver. Okay, so we are done with this step right here, putting in our values. Now we're going to ask it to take these values and write an equation. So we're going to go back to the stat. You don't have to save anything. It automatically saves it. So if we hit stat, we have to right arrow over to calculate. We want it to write an equation. So 4, and then we're going to hit enter. And there it is. Look, A is our slope of about 14, so it looks like 14 feet per year. And B is our y-intercept. It looks like we started about 127 feet in 1988. Okay, so let's go ahead and write those down. Our slope is 14, about 14. Our y-intercept is about 127. That is the closest and the best numbers that we can get because that calculator does an amazing program for that. So we're just going to thank it for doing its little job. I'm going to put enter here just in case we don't quite know what to do after that. Okay, so here we go. We have an equation that says our vertical drop is 14 feet per year plus the 127 that we started with. Okay, so the very last thing that we had to do, 30 years after 1988, what's the biggest drop we're going to have? We're going to plug that 30 in there, and we're going to get a very big number. And I can vouch for that because I just went on the Tower of Terror, and oh my goodness, that was a big enough drop for me. 547. Okay, so 30 years after 1988, we have a drop of 547 feet. And I am running out of room, so where am I going to put that? Drop will be around 547 feet. So, are scatter plots a little bit of time? Yes, they are. But using that calculator really does help. Okay, so use these steps for guided practice too. Okay, good news on that problem. It did just say to make a scatter plot and determine what relationship existed, if any. So what I did, I wasn't really lazy, but I did try to make my graph look really nice. I didn't want to write 2000 here, 2001. So what I did was I said years since 2000, just like they did up here. So 2000 was actually this point right here. I actually realized I was dealing with some big numbers, and I didn't want to deal with big numbers. So I labeled this sales in thousand. So 1 actually represents 1,000. That's why in 2000, I had about 13,215 here. Okay, so again, wasn't being lazy. I just realized I wanted my graph to look pretty presentable. Then I plotted those points, and I realized now I actually had a negative correlation. So determine what relationship exists, if any. As the years increase, the sales are decreasing. So I'm going to say that this is a negative correlation. Okay, so if having to graph, look at that, figure out the best way to present your graph. Okay, in a lesson a while ago, we learned that linear extrapolation is used to predict values outside the range of data. And we dealt with this a little bit, but not too much. But same thing with linear interpolation. You can also use a linear equation to predict values inside the range of data. And actually, we did use linear extrapolation right here, because that 30 is outside our range of data. So this is linear extrapolation. Okay, we are supposed to use the scatter plot to find the approximate number of United States travelers to international countries in 1996. So notice this is years since 1990. 1996 is probably right about here-ish. Okay, so we could almost guesstimate it right here. They want us to go ahead and go through the steps to find a line of fit and all of that. So we are going to do that with this right here. Okay, we are going to figure out these 2 points. They plotted it for us. They found the line of fit. That was all very nice. Now we're going to look at the 2 points that they gave us right here. So they told us that in year 0, in 1990, we had 44,623 travelers. They also gave us this point right here. So in year 18, we had 63,554. Okay, with that information, we can take those 2 points, which lie right on our line of fit, so we know that those are really good points to use. We're going to find the slope, plug it into point slope, and figure out an equation, so then we can estimate that. So we're going to take our 63,554, we're going to subtract our 44,623. We're going to divide that by 18 minus 0. Okay, that's roughly around 1,052 new travelers per year. So there's our slope. Now we're going to use one of these points for our point slope. Let's go ahead and use the one that deals with 0. That's really nice. So there's our y value. There's our x value. Okay, I'm going to write my point slope formula. Understanding that my x and y stay the same, I'm going to use my slope. I'm going to use my really nice x value and my really big y value and go ahead and do some distributing. So I have y minus 44,623 equals my 10,520 travelers per year. But look at this, 10,520 and distributing that through here. Actually, let's do one extra step here just to make this nice and pretty. I know it's a lot of rewriting, but that way we go through all the steps. 10,052 travelers per year. Year 0, though, I'm going to say that that's 0 right there, which means all I have to do is add over this, and I have my equation. So, final equation, 10,052 travelers per year, and I started with 44,623. Okay, I'm not even done yet because it says that we're supposed to use the scatter plot to find the travelers to international countries in 1996. So we understand that that's 6 years after 1990. So I know that x equals 6. I'm going to plug that in, and then I will be done. So basically what we just did was exactly what our calculator would do, except our calculator includes all of these and does a really fancy formula. Okay, this gives us a grand total of 50,935 travelers. Okay, all of that work to find that one magic number. So, option number 3 of how to work scatter plots. Usually that works really well if you do have a scatter plot and you don't have a table to base it off of. So you do have to find 2 nice little points. However, guided practice 3 says we're supposed to plug this into our calculator, find that line of fit, and figure out how many sales there were in 2015. As a hint, you could, in list 1, you could just write this as year 0, 1, 2, 3, and 4. You can also put that 2000 in there however you want to do it, but realize this is your list 1 and this is your list 2 values. So go ahead and try this out in your calculator to figure out sales in 2015. Okay, before we go any further, if you go into stat and edit, that information is going to be there from last time. So in order to get rid of it, you have to go all the way up to list 1 and highlight it, hit the clear button, then enter. Okay, so then you would have to go over to list 2. I already cleared it, but highlight list 2, clear, enter. All right, now you can be. Okay, so plugging this into our calculator, we find out our slope is negative 890, which does make sense because remember that our sales are decreasing by about 890 CDs per year, plus the 13,967, which is where we started. Pretty close. We started at 13,215, but again, calculator includes all of these other different numbers in there. So with that, I used that equation. I plugged in 15, and the reason being when I did my list, this I actually plugged in as 0 and as 1, 2, and so on. Okay, if you plugged it in as 2006 and 2007, you would have had to plug in 2015 there in order to receive the correct answer. So some pretty cool handy dandy calculator work here, realizing that our answer, the final answer we were looking for, was just 617 CDs in 2015. Make sure that you use those steps. Understand that there's 3 different ways, depending on what kind of information you're looking for, as to how to work these scatter plots. All right, you are now ready for the assignment for this section.